At 7:17 in the morning, on June 30th, 1908, the sky over central Siberia tore open. Witnesses more than 60 kilometers away described a column of blue-white light brighter than the sun, followed by a heat so intense they felt their skin burning through their clothes. Then came the shock wave. It knocked people off their feet, shattered windows hundreds of kilometers away, and flattened an estimated 80 million trees across more than 2,000 square kilometers of forest, all of them lying on the ground in the same direction, pointing outward from a single point, like blades of grass pressed flat by a giant invisible hand. And yet, when scientists finally reached the site nearly 2 decades later, they found something that made absolutely no sense. There was no crater. Nothing had hit the ground. Whatever caused the most powerful impact event in recorded history had detonated in the sky and left almost no physical trace behind. So what actually exploded over Siberia that morning, and why, more than a century later, are scientists still arguing about the answer? The remoteness of the location is the first reason this event took so long to investigate. The blast occurred over the Tunguska River region in Siberia, one of the most isolated landscapes on Earth, hundreds of kilometers from the nearest town. In 1908, Russia was under the Tsarist government. Communication was slow, and reports from the handful of witnesses who lived near the blast site took months to reach scientific institutions in St. Petersburg. Then came the First World War, followed by the Russian Revolution and a brutal civil war. An expedition to investigate a mysterious explosion in the frozen middle of nowhere was simply not a priority for a country tearing itself apart. The site sat untouched, unexamined, and almost forgotten for 19 years. In 1927, a Soviet mineralogist named Leonid Kulik finally organized an expedition to reach the epicenter. Kulik had a specific theory in mind. He believed a massive iron meteorite had struck the Earth, and he intended to find the crater, and with it, valuable iron ore he hoped the young Soviet state could mine. He assembled a team, hired local guides, and pushed through hundreds of kilometers of near-impassable frozen wilderness, swamp, and taiga forest to reach the coordinates witnesses had described nearly 2 decades earlier. What Kulik found when he finally arrived stopped him in his tracks. Every prediction he had built his expedition around turned out to be wrong. The forest around the epicenter was devastated on a scale that defied explanation. Trees for kilometers in every direction had been snapped at the trunk and knocked flat, all lying in the same radial pattern, pointing away from a central point, as if an invisible explosion had detonated directly above the treetops. This alone told Kulik the blast had not come from a meteorite plowing into the ground. A ground impact leaves debris scattered in a chaotic pattern near the crater, not trees neatly aligned in rings stretching for dozens of kilometers. But it was what Kulik did not find that truly baffled him. There was no crater anywhere, no massive hole in the earth, no smoking pit filled with twisted iron ore waiting to be mined. At the very center of the devastation, strangely, a small patch of trees was left standing upright, stripped bare of branches and bark, but still rooted in the ground, like a tiny island of survival inside a ring of total destruction. Scientists later nicknamed this eerie, surviving patch the telegraph pole forest, and its existence became one of the strongest clues to what had actually happened. Kulik spent years returning to the site, drilling into the swampy ground, searching desperately for buried meteorite fragments. He found nothing. No iron, no stone, no crater. The evidence he expected simply was not there, and an explosion powerful enough to flatten a forest the size of a major city should have left something behind. The absence of a crater forced scientists to completely rethink what kind of event they were dealing with. If a solid object had struck the ground, there would be a hole. If there was no hole, then whatever caused this destruction never actually reached the ground at all. The leading theory that eventually emerged among researchers was that a rocky asteroid, or possibly an icy comet fragment, roughly 50 to 60 meters across, entered the atmosphere at extremely high speed and detonated in midair, somewhere between 5 and 10 kilometers above the surface. As the object plunged through the atmosphere, immense pressure and friction built up faster than the object's structure could withstand, and it essentially shattered and vaporized in a single catastrophic airburst, releasing energy scientists now estimate at somewhere between 10 and 15 megatons. roughly 1,000 times more powerful than the atomic bomb dropped on Hiroshima. An explosion of that scale happening in open sky rather than on impact with the ground explained almost every strange detail Kulik had documented. The shockwave radiating outward and downward from a point high in the atmosphere would flatten trees in a radial pattern for dozens of kilometers, exactly as found. It would generate enough heat to scorch and ignite branches and bark without ever touching solid ground, exactly matching the burn patterns discovered on surviving trees. And directly beneath the blast, where the shockwave traveled almost straight down before spreading outward, trees could theoretically be stripped of their branches by the force, but remain standing, upright, if the blast wave hit it close to a vertical angle. The telegraph pole forest, the detail that once seemed like the strangest anomaly of all, turned out to be one of the clearest fingerprints of an airburst explosion. This shift in understanding had consequences reaching far beyond a remote Siberian forest. For most of history, the assumption had been that a dangerous space object needed to physically strike the Earth to cause serious damage. Tunguska proved that assumption wrong. An object never even needs to touch the ground to level a city-sized area, and an asteroid only 50 to 60 meters wide, small enough that modern telescopes can still struggle to detect similar-sized objects approaching Earth today, was enough to do it. Scientists studying planetary defense now treat the Tunguska event as a benchmark case, a real historical example proving that mid-sized, difficult-to-detect space objects pose a genuine and immediate risk, not just a theoretical one confined to science fiction. Because the true cause remained scientifically unconfirmed for decades, and because the Soviet Union kept the isolated region largely closed to outside researchers for much of the 20th century, an entire ecosystem of alternative explanations grew up around the mystery. Some claim the explosion was caused by a crashed alien spacecraft, its propulsion system detonating mid-flight. Others proposed it was the result of a secret, catastrophic experiment by the inventor Nikola Tesla, testing a powerful energy weapon from thousands of kilometers away. These theories spread for a simple reason: without a crater, without recovered debris, and without immediate scientific access to the site, the absence of hard physical evidence left a vacuum that speculation happily filled. Modern research has steadily closed that vacuum. Since the late 20th century, expeditions using improved forensic techniques have recovered microscopic mineral fragments in the soil and peat layers around the blast site, containing trace signatures consistent with meteoritic material rather than any terrestrial or artificial source. Simulations modeling asteroid airburst physics, refined using data from more recent and far better documented events, have successfully reproduced the radial treefall pattern and the surviving central zone almost exactly. The most well-known modern comparison came in 2013, when a much smaller asteroid, only about 20 meters across, entered the atmosphere over Chelyabinsk, Russia, and detonated in an airburst roughly 30 kilometers above the ground. It was captured on hundreds of dashcam videos, injured over 1,000 people from shattered glass and shockwave damage, and gave scientists modern, precisely measured data confirming that airburst explosions behave exactly the way the Tunguska theory predicted. Chelyabinsk did not solve Tunguska by itself, but it gave researchers a real, filmed, instrumented example of the exact type of event they had been reconstructing from century-old tree patterns and eyewitness accounts. Despite over a century of research, mysteries still remain. Scientists still debate the object's precise size, composition, and trajectory, since no confirmed fragment large enough to fully settle the debate has ever been recovered. Some researchers argue it was a stony asteroid. Others favor an icy, fragile comet piece that would explain why it disintegrated so completely without leaving substantial debris. What almost the entire scientific community agrees on, however, is that whatever it was, it came from space. It detonated in the atmosphere, and it delivered a shockwave powerful enough to be recorded on seismographs and air pressure instruments across the entire planet, circling the Earth more than once. More than 100 years later, the Tunguska forest has partially regrown. Trees now stand across much of the blast zone, and from above, the landscape looks almost ordinary again, nature slowly folding the scar back into itself. But scientists studying the region can still trace the radial pattern in tree age and growth rings, a faint but permanent signature of the morning the sky exploded over Siberia. Somewhere out in the solar system today, similar objects, 50 or 60 meters wide, are still crossing paths with Earth's orbit, largely undetected by current tracking systems, and the only reason most of us have never heard their names is that they have not yet arrived. Tunguska remains the largest reminder in modern history that the sky above us is not empty, and that the next warning may not come with nearly as much time to prepare.